Evening, Professor. This is my personal timetable. So before to start my plan for this week, so I just want to explain the what time we have taken for our experiment. So as we have discussed in the last meeting, so I just make the comparison table like in which step we have to spend how much time. So first of all, we did the piranha and we make the 1 to 1 ratio of the chemicals and then dip into the solution and wait for like 20 minutes at 80 degrees Celsius. Basically, after the piranha, it's the OH ions activated onto the surface, and then we prepared the graphene oxide solution with ethanol, and then after the immobilization we use hot plate and to wait for the drying and some annealing process called curling process annealed over the surface. So it takes 30 minutes to activate, and after the annealing process we use EDCNHS dissolved with ethanol, and it takes 10 minutes for binding, but we have to wait for 30 minutes until dry and it's amide bond activated. So after EDCNHS we have to wash with ethanol and then wash with the ethanol, and then afterwards we use antibody immobilization onto the surface. An antibody made up by the PBS. It's a drop casting method. It's a 10 minutes for binding, but we have to wait for the drying, and I don't think so we have to wait for the 1 day or 2 day, but as per I have read several articles, and in further I will explain in the next slide that they don't need so much time for this thing, but our case is like we have to wait until dry, so that's why it takes so much time. But for now, if we start, then we have to just wait until like 10 minutes, or wait for drying is like 30 minutes or 1 hour or 2 hour maximum. And then afterwards BSA immobilization we mix with the TBST. It's a different kind of liquid that we have to use, mix up with the solution, and then it's a hydrogen bonding formation onto the surface, and it takes 5 minutes. It's a washing technique, so that's why we use here BSA as a blocking, and then afterwards washing and then antigen immobilization. So basically I have read several articles that even I also talked with my seniors in a UK or as well as in Sweden. So I found that it does not take so much time for the interaction of antibody and antigen. So it's maybe it's maximum to maximum it's like 10 seconds, but if I say in molecular biology studies, so it takes milliseconds for the binding, but as we already talked that we have to wait for the drying, so that's why it takes more than 10 minutes or 20 minutes. But otherwise the interaction it takes only in 10 seconds or less than 10 seconds, called milliseconds. And then afterwards we have to wash with the PBS, and then we have to check the capacitance value, whether the changes in terms of different capacitance. So it's a summary of each step. So with piranha takes 20 minutes, and then afterwards graphene oxide immobilization and annealing is like 30 minutes, and then ADC and HS take 10 minutes for binding and 30 minutes for drying, and then antibody immobilization less than 10 minutes, and then BSA washing it takes 5 minutes for drying, and then afterwards AG mobilization it does not take more than the half an hour or like something 1 hour. It just take only milliseconds or maximum to maximum 10 seconds for the interaction of antibody and antigen. But unfortunately, because of having our liquid, our solvent, we have to wait for drying, that's why it takes more than time. But as per my this glossary for this and for summary of this, so it takes total 75 to 80 or like maximum 3 hours for whole step reaction, maximum 3 hours. So as I already told that we have to use the new method for the immobilization, so I have to choose these two things like D5 and P6. Why I'm using D5? Because it's having the double interdigital capacitor factor, and but for the P6 is having the good stability. So that's why I just use this two, and then afterwards I have to use this chip for the electrochemical deposition. So it's an electrochemical method, so I have to use these two chips. And before to use the electrochemical machine, I have to I have to wash with the piranha cleaning, and because of the surface hydrophilicity. So first of all I have to make the surface hydrophilic, and then I have to use the electrochemical method for the deposition of any kind of solvent or like something if you want to, but in our case we have to make the three different kind of solution. Later I will explain what the solution is it, but before this I just want to explain the why we are using here electrochemical method for this our case. Why? Because the conductive layer on the electric communication on the wafer is a very strong first, and the second one is the resistance is more stronger than the other two methods like spray coating and the dip coating um, and any other method, but I prefer this method because it's a more stable, more sensitive, and as well as more strength. That's why I am focusing on this one. And also it's more I know it's more complicated, but if I say with the compare with the other methods are not complicated, but this method is complicated, but it's a series of the reaction that takes place onto the surface, just like oxidation and the reduction. So if we use this one, so it's a linear or like very thin layer deposition in an equal way, and there is no instability onto the surface. That's why I'm just focusing on this method, and it's a very stable and effective results as well. So my main measurement criteria that I'm using this machine as a parameter. So first is the scan rate is a 50 millivolt per second, and the maximum current I have to use is like 2 ampere, but in our case I just I'm thinking to use less than 1 ampere, and the maximum voltage in the machine that I have seen this 10 volt, and the range is like 1 megahertz to 10 microhertz. This is the basic parameters of the machine. So, according to the discussion with the Dongmin, so I found that there are the several machines available in the South Korea and like nearby our university. So first, before to explain the existing machines, I have to just explain what I have used earlier, like in the in the time of PhD. So it's basically it's a machine having the four electrode condition connections. First is working electrode, counter electrode, reference electrode, and S and GND with 4 bananas plugs. Basically, the electrochemical machine is just a detection, but it's having the plug-in option. So we have to just plug it and then release the three kind of electrode like the same this one. It's the red one is the working, and the white one is the counter, and the blue one is the it's like a reference electrode. So basically usually in the EVM stat or like IEIS, any kind of electrochemical machine, the reference electrode and the counter electrode are same. Like the reference electrode is made up of the platinum is silver chloride or silver electrode, and in the counter electrode is always having the platinum wire. So it's the basically these are the specifications. First, this machine is told me about this machine by the Rinsang, but unfortunately this machine is not available from for our timings. So we just skip this one, and we are just focusing on this machine. It's another machine, but the working capability or like the performance is same as before the two machines. So it's basically it's machine to measure the current, like the capacity, like the electrochemical interface specifications. Basically they measure the current versus um, voltage graph, and then its potential state. Having the basic information, its advantages is like cheap, it does not at low temperature, and the nanomaterial deposition is very easy, not taking any time, but it, at least 10 minutes, not more than that. And then is easy, even complex shapes can be coated onto the surface. This is the basic, this is the positive attitude of this machine. So I did the literature survey. So I found that there are the various fabrication process in in the research field. So I found that the various processes like solution mixing and then deposition, sol gel method, and the hydrothermal self assembly that we are using is called self assembly, and the microwave radiation ball milling, and this one is electrochemical deposition. So basically that's our we have the Si2 wafer, and then we have the metal. So I just want to use this one, electrochemical deposition. Basically this machine having the capability to deposit any kind of material, that is having the aqueous solution or like any kind of solution, not so much viscosity in itself in the solution. So that's why I'm just focusing on this machine as well. So our main what I prepared for the deposition, uh, I use the D5 chip and the P6 chip. So first is the graphene oxide. This is the solution that I have to prepare and then use in this vial, and then we use this chip and this chip as a working electrode, and the deposit any kind of substances. First is graphene oxide, only graphene oxide, and then APTES, another solution, it's a two, and the third one is the mixing of these two. So once we got the immobilized chips like the D5 and P6, so my main next motto is to make this kind of this, but this is the example of that the person, any kind, several researchers doing this kind of method, that the graphene the graphene immobilized onto the surface via electrochemical method. They are using the PT electrode, but in our case we have the glass wafers and then titanium and the platinum. So it's is that electrode is working as a working electrode, and then we just, once we got the graphene oxide, and then we have to simply drop casting onto the surface like EDC, NHS, any kind of things we have to use this one. Once we got the graphene or APTS immobilized chip via electrochemical method, and then we have to use the same kind of biosensor recipe, and we don't use the spin coating, we just use only the drop casting, because the main carrier like the graphene oxide is easily deposited onto the surface in the linear and the thin film onto the surface. So we don't have to worry about that our the graphene value is not stable, and then what we have to do next. Due to, because of this machine, electrochemical machine, we have to tackle or like solve all the things that we face nowadays. So once we got the chips with the graphene oxide and with APTS and with the mixing of this, so I just use that. If we have the APTS chip, then I have to use this kind of method like EDC and I just mix with the EDC NHS with antibody, and then incubate for 1 hour uh, with the antibody, and then immobilize antibody, use BSA 30 minutes at 37 degrees Celsius, and then I just use the antigen. So my main thing is like once we got the chip after the electrochemical machine, then I used to use follow this procedure, and hopefully we will get the positive response, because my main motto is to first fix the first carrier like graphene oxide or either IPTS we will use in the future. And also the same, once we got the chip, and then I just use the EDC with antibody and mix together and then immobilize onto the surface via drop casting. No need to use spin coating. And then we just use the BSA for 30 minutes at room temperature, and it's a linear, it's a layer by layer method. And it's I'm pretty much sure that that method is quite easy and no need to be wait for a long time. And this one is other method, like once we got the graphene oxide where, like uh, this one or APTS chip, and then we use BSA with antibody and antigen. It's a basic a simple process they use. This paper is published in 2014 and that one is like 2017. So it's a layer by layer method. Why they are having the positive result? Because the carrier, the substrate, the substance, the first they use first time, like first onto the surface, is more stable and the thin film onto the surface. So that's my main focus, is to make the thin film via electrochemical method. And this bare ITO surface, and then they just use the Piranha solution 1 to 1 ratio, and then use APTS and glutaldehyde with the antibody. Here you can see that glutaldehyde mixed with the antibody. Glutaldehyde is mixed with the antibody and then immobilized onto the surface, and then afterwards once the antibody is attached, and then BSA will wash out, and then after antigen they used. So it's basically it's layer by layer methods. And I already told that the linear things we have to focus on, and no need to make the puzzle up with the various kind of recipe, and don't waste, we have to wait, we don't have to waste time. So I just want to request that first of all we have to focus on the only single things, like why, how we can stable our the graphene oxide or like APTS onto the surface. So that's why I've just main focus to make the electrochemical method. And I talked with the Dongmin said tomorrow he will call them, and then once we got the dates, if the machine is available, so our main priority to do the either on Wednesday or like Thursday or Friday or Saturday, I don't doesn't matter. Matter is to go and to deal with that and how it works. I just want to make the solution. So tomorrow Dongmin will call them to ask whether the machine, when the machine is available. So that one, this thing, so I have to focus on. And it's, I don't think so we have to, I have to explain this one because spin coating is not necessary for this case. Thank you, sir.